So you may be wondering by the name of these functions, especially these two, the secant and the tangent, why they are called what they are. In earlier math courses, you may have heard of a secant line, and a secant line is a line that passes through 2 points on a curve, on like a graph of a function. So there's 2 points, and there's that line. It just goes through them, and it just keeps on going forever and ever and ever. But that's a secant line. It passes through 2 points. A tangent line is a line that touches the curve at just a single point. So it's tangent to the curve. It just grazes it and just bounces right back off of it. All right, it doesn't touch it a second time locally. You know, if this thing curved back around or something, you know, that tangent line may hit it again. But locally, it only hits it at 1 point, whereas secant line locally it hits it by definition at 2 points. So you may be thinking, well, maybe that doesn't have anything to do with what we're talking about, because we just said like tangent is like the slope of this line that connects this, and we're not talking about a tangent line like hitting it this way. Well, that's true, but it's also not true. There is a way that we can come up with a tangent line to the curve here, and then a second point that goes through a secant line. So what we're going to do is I'm going to make a second point. I'm going to make a point here at the initial side, and I'm going to make a line tangent to the curve at that initial side. I'll make it dashed again because it's not really there. But if a line were tangent right here, you know, it would look something like that. I'll make it go down in the other quadrant too, because we don't know where this point right here is going to be. It could be, you know, there, it could be over here, it could be down here. But let's just say it's right here for just right now. All right, now I'm going to connect a point through the origin, through that point that we've put on the circle. I'm going to make it go through all the way through there. Okay, now we've got, now remember the radius, this is the unit circle, so the radius is 1. So the radius of this piece right here is 1 from here to here. Okay, now remember this right here, this little radius on the circle where it hits to this point right here is also 1. Okay, now this right here is just some arbitrary point xy, or just somewhere on the curve, so xy. So that means this line segment, let me change to a blue, this line segment right here is x, and then this right here is y. Alright, this part right here. Okay, now this is 1, this we don't know, this outer thing right here, this height, I don't know what this height is. Alright, it intersects the line that we're going through. Now typically we would stop it right here, we have been so far, but it's a line segment, I can make it keep going forever. So we're asking, well, how tall is this? What height would this line that's tangent to the unit circle, when would it hit our point where we put this, you know, where we stopped that rotation of the circle from the initial side to the terminal side? So what would be this height? Well, if you look really closely, I'm going to put it in here with a highlighter. You've got a right triangle right here, right? And this angle that's inside this right triangle is also the angle inside of this other right triangle, this smaller right triangle that's right here. Okay, so they both have that angle in common. All right, now what else do they have in common? Well, they have another angle in common, and the fact that we're going straight up off the positive x-axis, so that's a 90-degree angle. And this is going straight up off the positive x-axis, that's a 90-degree angle. So what does that mean about this last angle? That means that because this angle is shared by both, it is literally the same angle, and then they have the same second angle. That means that this third angle right here also has to be the same. So what does that mean? That means these two triangles, the yellow one, the bigger one, and the blue, smaller one, are similar, which means that we know the ratios of the sides are proportional. All right, so what does that mean? That means the ratio of this side right here, y over x, is proportional to the ratio of this side right here, the unknown, the question mark, over this side, which is 1. All right, well, question mark over 1, whatever this thing is, when you divide by 1, you get that same thing, so we end up with question mark equals y over x. Well, what's y over x? Y over x is the tangent. Oops, I can't use x. I gotta use tangent t. That was what our book is using for angles. Tangent of t. So what does that mean? The height of this thing, the tangent line, until it hits the line segment that goes from the origin through the point on the circle where that line hits the tangent line, is the tangent of that angle. So that's where it's getting its name from, because it's a tangent. Alright, now the trickier thing is this guy right here, the yellow side. Alright, we can set up another proportion to solve for that. Or sorry, not the yellow side, but the hypotenuse of the yellow triangle, I should say. But all the ratios are proportional, meaning the hypotenuse to either side is proportional to, and the yellow triangle is proportional to the hypotenuse for this other one. So if I did the hypotenuse, if I called this my unknown, I'm going to call it h for hypotenuse. That's this hypotenuse right here. H, the hypotenuse of the big triangle, is to 1, the horizontal part of the big triangle, as the hypotenuse of the little triangle is to x, the horizontal part of the smaller triangle. Alright, so h, that bigger triangle's hypotenuse, divided by 1 is just the bigger triangle's hypotenuse, equals 1 over x. Well, what's 1 over x? 1 over x is the reciprocal of the x coordinate. That's the secant. So secant t. Okay, and as we see, there's 2 points right here along that secant line, or you can think of 1, 2 right here if you want to call it that, and then just 1 point where it's touching on the circle for the tangent line. Alright, so the 2 points for the circle gives me the secant line just like it did before. 1 point is giving me the tangent line. So there's where they're getting their name from. There's visually why they have these names. You don't necessarily need to know that. The more important thing that you get from this first section of notes is tangent sine over cosine or y over x. And then above we saw the cosecant, oops, not that one, this one. This one, the secant is 1 over cosine. That's the big important thing. But just if you were wondering, you know, hey, I thought secant and tangent had to do with lines going through curves or touching curves. It does here too. It's just we have to kind of extend outside of the unit circle to see why these names are what they are.